Raghav, today we are going to solve a problem which is API rate limiting. Have you heard about it?
Yes, I do heard in my previous jobs, we have used some external vendor APIs,
Hmm.
and I think they share the limits under this boundary only you can use their API based on the plans which we are buying. Is it the
Sure.
same?
So today we are going to design it ourselves. So basically, our goal is we want to throttle the users based on the number of requests they are sending. So, so that is like a requirement for us.
Mhm. So, so who would be our users? It can be end users would be anyone like a service. It can be service or it would be end user.
It would be anybody who's calling that API. So we want to throttle a API, and it could be anybody. It could be users. It could be another API which is calling that API. So
Okay.
yeah.
Mhm. And the API which we are going to throttle, is it a particular API in a particular domain area? Like it can be a
So
image API
basically,
or it can be generic API, anything.
no. So we are not concerned about the API here. We are
Mhm.
concerned about building a system which would work as a. So I can use that throttling system anywhere after that. So So let's say I build a throttling system and then I can use it anywhere. So so it's basically on the throttling how you will do it rather than I'm right now not focused like how you will use for a particular API.
Got it. Got it. Noted. Um, so is there any number you have in mind, like how many requests we are going to throttle, uh, like per second, per minute, or it can be generic?
It could be see again so like you mentioned you have used this API rate limiter. So apparently we define rules ourselves. So I'm fine going very simple right now, but it could depend. Like for this API, I only want 10 requests per second, so or 100 requests per second, so something like this. But right now, to start with, we are fine with doing any in any manner.
Sure. And what would be a scale of this API limiter? Like it would be going to use by large number of audience or mid-size or startup? Do you have any users in mind?
So think like right now we'll make it as a on a public cloud, so anybody can use it.
Okay. So so can is it a fair assumption that it should work in a distributed environment?
Uh, yes, it would be in the distributed environment.
Okay. So w- as we are going to do the throttling of the APIs, so how what would be our client identification? Would it be like IP level we have to identified or client ID? Because usually based on the API provider,
Mhm.
sometimes they give the client ID and based on that they measure and throttle the request,
So
or
yeah,
it would be based on the IP.
so we can make it right now really simple. Like let's say there would be a client ID associated with the request, a client identifier, so we can use it.
Okay. Okay. So back of my mind, I'm thinking about the rules also. Like, would it be any rules involved here? Like, uh, based on the plans or something like that. If client A is having plan number A, so he can use, or that particular client can use 100,000 requests. Do we have any such kind of rules also we have to? check while
So,
limiting our APIs?
so we can define rules in the system, but right now I'm not that much concerned about the rules. So you can start with any simple rules like can some kind of a 10 requests per second or something like this. Like, and the rules would be same for everybody for now.
Okay, makes sense. Um, so coming to the non-functional requirements, I would like to take some of inputs from you. Uh, uh, so what does fault tolerance, such kind of things are important if any situation our system goes down, so should it work highly available?
Yeah, so I feel like API rate limiter should be highly available and it should have a tall following. Like you won't want to a system like if you call it and
Abs-
it takes too much time to process or gives you wrong result. There could be a factor of error, but it should be highly available, highly kind of a fault tolerant.
yeah, I think I'm good in the requirements part. So do you think is there anything specifically which I haven't covered, or would you like me to mention here in requirements or non-functional requirements? Or we can kickstart it and on the go we can evolve our requirements.
I think, yeah, this is fine to get started. So, mhm,
Um, okay. So
mhm,
as we are going to do the rate limiter, so we would be having. I'm just drawing a very high level um design, how it's like what how the high level workflow should looks like.
mhm.
So So what we are going to solve here, if we have a client can be
Mhm,
anyone. Okay, if client is sending multiple requests uh,
mhm,
to the API server. So I'm trying. I think before it hits to the API server. So I think the position or the location of our rate limiter before hitting to the actual API servers itself,
mhm,
where we are going to distinguish if, as you mentioned, 10 requests per second. So likewise, if I'm sending 10 requests or more than 10 requests in within a second, say for example, likewise I'm sending so
mhm.
from 1 to 11th. So if 11th request comes within 1 second, so I'm going to discard this last request. So so we are going to design this particular component a part of this
Yeah.
interview. And okay, so I forgot to ask one thing. So if we are going to reject the request, so what we will do? Are we going to drop the request? We are going to notify to the client, or we are going to put it in a queue?
No, so I think we need to drop it. So I think there's a HTTP status code. I forget that it's like I think
Yeah, I think.
yeah. So you can send it back like too many requests, so client will know like the client should not bombard.
Okay. Okay. So what I'm thinking that we should, as we are going to design this rate limiter, we may need one more component here. Sorry about this. So which I can call as a counter component. So what rate limiter is going to identify, or we need some kind of counter component which will help us to know, like for this particular client, whether we have uh, over the counter limit or below the counter limit. So based on that, rate limiter will decide whether to reject it or accept it.
Okay. So how this counter component will work?
Um, so we can think of algorithms which can, in industry level we have some popular algorithms like a bucket algorithm. uh,
Okay.
what I can think of is like token bucket algorithm. So what we can do, we can prepare some sort of bucket or container using which will be associated. Maybe I can. Okay, let's consider this is my bucket. Okay, so for bucket there will be a, what I'm thinking that every client would be having a unique bucket. Okay, and based on the rules or based on the plan. Okay, so the bucket would be having some number, like as you mentioned, 10 requests per second. So
Mm-hmm.
we can initialize our bucket with the 10. Okay, so 10 10 is just a number we are initializing while creating a bucket for a client. And then we can have some sort of like likewise. So we have these tokens available up to 10. Okay, and whenever the request comes in, so rate limiter can check this counter component, and counter component further check the bucket for this particular client, and see whether how many tokens or how many counts I have. So these dots are just representing the tokens or the counts here.
Mm-hmm.
So say for example, you mentioned in the beginning, in a situation of 10 requests per second. So um, we at so maybe at 100th millisecond or first second. Okay, so two requests came. So what we are going to do, we are going to go, it will go to the rate limiter. Rate limiter can go to the counter component for this bucket check,
Mm-hmm.
and can further see consume two tokens out from this bucket.
Mm-hmm.
So it means my bucket has remaining uh, 8 tokens left. So if so, then as in we proceed, let's suppose at the 200 millisecond time range,
Mm-hmm.
again 3 requests came. So it means again I will go and check my bucket. So and I still have 8 tokens. I think I'm good to consume the uh, tokens for my fulfilling these 3 requests, and I have again 5 tokens. So likewise I will keep on uh, checking whether my bucket has anything remaining, tokens or counts. If uh, if I don't have anything remaining left in my bucket, then it means I'm out of my limit. So my this counter component would return some sort of message or a return variable to the rate limiter, like a boolean false. You cannot go further, and based on that, this request is going to reject. So this is what I'm thinking at very high level design.
Okay.
Um,
And when you will refill your bucket?
when it depends upon, okay, so let's do a little bit of cleanup here. so the question is when I can going to refill this bucket.
Mm-hmm.
So that is something I'm going to decide based on my rules. Like um, um, like we have to keep on refilling our uh, bucket maybe every second. So if it is already a so question, okay, when I'm going to refill this bucket, so I'm going to define we the system is going to define a threshold limit or a product limit at that particular second. System is going to put refill the buckets automatically.
Okay. Okay. So just want to say like you won't have one you won't have one API. You will have a lot of APIs, and different APIs could have their different rules. Some say like I want only 10. Some APIs say like, oh, I allow 100, or some APIs I also allow 1,000 requests per second. How you will manage that?
So so it means every we are going to have a the rate limiter component we have to attach to the particular service level. Okay,
Yes.
so like the bucket we can have a bucket this particular bucket against every endpoint. So say for example I have an endpoint.
No, yeah, that's fine. But how you will organize it? Like how you will make sure like how your backend would look like, how the database would look like how you will manage all these things.
So in um so what we would be having like we can create like multiple rate limiters like this component. Okay, so then this rate limiter uh, can talk to different APIs,
Mm-hmm.
API 1, API 2. So likewise we can um,
These are two different APIs, right? API 1, API 2.
yeah, API 1 and API 2.
Mm-hmm.
So API 1 and API 2 uh, because rate limiter component should be intelligent enough. Okay, uh, which particular API request came. So based on that, um, it will identify. Okay, so what I can do, I can draw one more diagram. So better, which would be having all the. So basically, also we can think of a rule service point of view also. So so rule service which will define
Mm-hmm.
like this particular API one has only 500 requests you can um, allow per minute or
Mm-hmm.
per second,
Okay.
and all that static or master information would be residing in this rules API. So first, so so once the request comes in, so very first time uh, it goes to the client identifier. So we can identify who is our client, okay, which is our client, and then we can go to the rate limiter calculator, rate rate limiter calculator, and this rate limiter can go to this particular component, like to identify it's like a rules resolver, not a throttle resolver. It's more like a rule resolver, which will, maybe we can have a different service running separately, rule service, and
Mhm.
then further we have a rules DB. So this rules DB would be nothing but which will be holding all the information about our all the different APIs. Okay,
Mhm.
so again we can have a projection of so this rules DB would be having projection of all the APIs, uh, like API 1, what rule it has, okay, and API 2, what rule it has. So this DB would be holding all the information of these APIs, and once it will return back, the rule service would return back the information to the resolver, and rate limiter will would be holding uh, would, based on this rules information. So
Mhm.
this rate limiter component uh, can create a buckets internally. So the projection of maybe, so this would be having uh, maybe I can, so then this would be holding it, or it will create the buckets dynamically based on
Mhm.
the uh, response it is receiving from the rules resolver class. Okay, yeah. So then likewise we can have the buckets uh, created, and each bucket would be having in the previous diagram the tokens or the counters initialized. So when the new request come, so we can go back to the rules resolver, and or this component should be intelligent enough to find it out when was the last refill happened, and based on that we can do the refill again.
Mhm.
So when was the last call came, so we can refill, or we can run a job scheduler kind of thing, which would be refilling this bucket.
Mhm.
And then finally, if we are saying, okay, if it is allowing, then if rate limited calculator says, yes, this looks okay to me, this request looks okay, then only we can go to the request processor. And request processor would be having this API, actual our app server. It can go to the actual API app server. So if in situation of we are not, uh, if rejection happened here, so then we can send the response back uh, to the client.
Mhm.
Uh, so here we can send the whatever HTTP code, maybe uh, too many requests.
Mm-hmm.
And also we can think of some response headers uh, just to give more information to the user, like what exactly happened, uh, when you can retry again.
So, Raghav, so so one API rate limiter can support multiple APIs, right? So how you will scale your rate limiter thing, and it could support like tons of APIs in your organization.
So yeah, that's very interesting thing, because the load balance, that's a good question, I think. So usually in typical any distributed system, oops, I think, is it okay if I can delete these couple of images? I think this
Uh,
system,
you can have
or
another Lucid chart open if you
maybe,
want.
yeah, let's see if, I'm sorry about this. I did not notice. I thought this is a good tool to use.
Okay, you can remove few things or take a screenshot
Yeah,
and
that is a good thought.
I think after taking a screenshot, you can even paste it here.
Yeah, that would be treated as one. Okay, so coming back to your question, so what usually we have a load balancer, okay, which identify to which host you want to send request, okay, because in a distributed environment, usually we have multiple hosts involved, and uh, now the rate limiter component would be running uh, at this individual host level.
Mhm.
So the challenge would be, so now we have no idea like whether the request has gone to this particular host or this particular host, and the counter information which this rate limiter is holding uh, does not know what is the, if the previous request went to this host number two. So it means we have to come up with the some kind of approach where these hosts can share the information with each other, like what is a, like if host number one rate limiter has consumed uh, two requests earlier,
Mhm.
okay, in the current 100 millisecond, and this has got another maybe 10 requests, okay, so
Mhm.
we have to reject uh, the last two requests, because the our initial requirement for this particular client is only maximum 10, but this already two has been consumed. So we have to, one option could be we can come up with the either the request should go to the previous host only, like we have something called a sticky session, but I won't recommend that thing here, because it may work for our large, sorry, smaller set of users, or if our number of users are less. But as system has to be fully scalable, okay, uh, then that does not make a actual, does not make make the actual solution or system as a fully distributed in nature. So what we can do is we can uh, inform to these host, okay, uh, uh, if we have multiple hosts are there, then these hosts can tell to each other, okay, what is my counter information. Or we can have also, we can think of a common component cache kind of thing, Redis cache or something like that. uh, and every host can talk to this common system, which will be holding all the counters information for each client.
Okay,
And
but your counters could again be in a common system, right? So all the hosts can talk to the same counter server, whatever.
uh, we can pull out that information out from the host, and we can start storing uh, in a common component. Okay, so if that helps. Or other option could be, because this is more like a, every host is talking to this distributed cache, okay, and getting that counter information. Let's suppose if client A, this host one has already fulfilled two requests of client A, then we will go to this cache. The host one will update the counter of client A in this common cache. If host two get now next getting further 10 requests from the same client, before fulfilling the request, the rate limiter go and make a check to this common distributed cache. Okay, tell me how many requests client A has already fulfilled. For the client A, how many requests has been already fulfilled, and based on that information, the rate limiter uh, can decide the bucket handling accordingly, which we have discussed in the previous diagram.
Okay. So do you think
Or
that
otherwise we have to keep on sharing. Let's suppose if we have, right now we're talking about only two hosts, but in actual scenario there could be a more than two hosts. Then otherwise every host has to uh, keep on informing to rest of the n minus one host, okay, that this is the information I have for a
so?
counter.
So that's a good point. So how they will know each other, and if you add a new host, how you will manage that?
There are a couple of things are okay, I think I need to take a screenshot first. Sorry about this. So what we can think about that is the question, or the thoughts which you are projecting here, like how multiple hosts are there, and if new host is coming into picture all of a sudden, so then they should be having some host registry, okay, which would be maintaining all the information of the host, okay. And let's suppose, whenever the new host is getting introduced, so that particular host has to register itself to the common registry, and that common registry would be always in sync with rest of the host. So the host 3 is coming into picture as we are scaling up. So every host would be uh, in sync with common registry, and based on that, because this common registry would be in connect with the rest of the hosts, so that's how the other host will get to know, like new host has come into picture. Then 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 there are different approaches we can think upon, like how these hosts are going to talk to each other for sharing the information about the rate limiter counters. So Yeah, one option we discussed about earlier, right, is cache, common kind of distributed cache, or otherwise randomly one can become the leader. There is a leader, one can become the leader, and that leader can take the responsibility of informing to rest of the host. Okay, this is the updated counter information I have for all the clients.
Okay. So do you see single point of failures in the system?
Um,
So let's say if my
if
API rate limiter is down, then nobody would be able to reach my API.
um, Not 100%, because if in this example, if you see, let's
Mhm.
suppose the host one rate limiter is going down all of a sudden. So I do have a load balancer that will started routing the request for my host number two or further to other hosts which are available. And um, just in and the existing two request which is served by the host number one which went down, that information we already have in a further distributed manner at a Redis cache. So even if the Redis cache level also some failure happened, again that is distributed in nature. We would be holding that information somewhere else also, and always we would be having updated counter information for host two can go to the Redis cache, which is again distributed environment. So it would get that information here. Does it answer your
But the
question,
thing
Asim?
is, to make it highly available, you added a lot of components here, which can slow down the entire system. So let's say if so this has to be really quick, because if I say like my API supports of SLA of 100 milliseconds, but if this whole thing takes like more than 100 milliseconds, then it will add to the response time for the actual API. So I see there are a couple of things which I see it should be either really quick or it has to be simplified down. For example, you have this load balancer, then you have all the hosts talking to each other, then there is a caching layer involved. Like everywhere there would be some uh, communication which will add more times. And if I say my API itself is 100 millisecond, it may not able to achieve that SLA.
Mhm. Uh, because we are trying to why we introduce, see, these multiple hosts, this, if this goes down or this comes into picture,
Mm-hmm.
uh, so uh, whenever the new host comes or new or our existing host goes down, so our API response time would not depend for sure on this part, if I'm right, or
But
correct me if I'm wrong.
it have to
Because
read out to other host and you have to bring another host in the system in parallel.
Mhm,
And and on top of it, there might be another load balancer in front of your API,
mhm,
because your API could also be distributed. So I'm just trying to see like there are so many
mhm,
components here. Would that slow
mhm.
down the entire system or not?
I think the way we are our distributed system is being designed. Okay,
Mhm.
so I think it has pretty fairly good SLA over there. Like the new system comes into picture. Always we know that multiple hosts will be always online. Okay, uh, the kind of distributed systems we have right now. Uh,
Mhm.
if
So,
if I
do,
understand your question right, so go ahead. Sorry.
no, do you think any other alternate design could be possible here?
Yeah, maybe then we can have a rate limiter we can pull out from here. Okay, altogether, uh, and uh, we can take out from the host level, and we
Mhm.
can uh, like this rate limiter which we are associating to the host level, we can have somewhere outside.
Okay. Okay, I think we are almost at the end of the interview. So anything you want to, you have any closing thoughts you want to wrap up?
Um, yeah, that's very interesting problem statement we have discussed. Okay, and it's a very common problem in the industry. So, um, my closing thoughts would be like we can further dig into the algorithm level, and we can further define the classes uh, quickly, like what kind of classes object rented in within the rate limiter we would be having, and we can uh, calculate whether the rate limiter, how much space it requires, okay, for the initial. So based on our client size, how many requests, and we can calculate that, and based on that we can stand up our initial host and servers accordingly, uh, and we can further tune. There are other algorithms are also involved apart from token bucket. This is the one approach I came to my head, and I explained it here. We have some other approaches are also available, where we can further fine tune the algorithm based on our need. Yeah, that's all from my side. Thank you.
Okay, awesome. Okay, thank you, Raghav. This makes the end of the interview. So, so with this, what we do next is Raghav can do a self-assessment. So the points he is bringing up himself, so we don't need to repeat it. Followed by any quick feedback from the audience, and then I can give my feedback. So, Raghav, do you want to do a self-assessment, or you need time for that to
Yeah,
regather your thoughts?
yeah, I think yeah, I can talk as as the flow. I think you gave couple of hints and couple of places I stuck. Like one maybe uh, the entire discussion went from uh, to the distributed nature. Okay, because I introduced multiple hosts, multiple servers. So I was bit. I was not confident enough whether I'm in the right direction, or I'm going out of the scope of the original problem statement have been asked. So like, and then you in the end, I think you gave me a good idea or hint, like the entire system may be single point of failure, or the it would lag overall response time if such so many communication would be there. Looks like I have overcomplicated the simple problem. That is my self assessment. I could have given a pause and rethink back and revisit my previous original diagram, because I introduced so many components. That is my improvement point I can think of right now.
Okay, cool,
Uh,
cool. Thanks, Raghav. So, I would open the floor for the audience. Like they can give a quick constructive feedback only about how what Raghav did well and how he can improve, and anything related to technical thing will cover it bit later in the session. So, anyone has any feedback?
I think this is really good. One question I have is like when interviewer is thinking. So let's say, for example, he has too many components here. Should he start, even though he knows, should he start with less components and then keep improving on top of it? Or if he has already a end solution, should he start with an end solution? What's the strategy that he should follow?
So, okay, so sorry, I would like to cover any questions on the design or anything bit later.
Okay.
But I can give a quick answer that it was like a challenging question for him. Like I want to challenge him to think different and see how he comes up with thing. That could not mean like he was right or wrong. That could mean like I just want to challenge him in a different direction and see how. It's more about like I want to grab where what is his strong areas, how he think different. It doesn't mean like he was doing something wrong.
Okay.
But do you have any feedback in general for Raghav? Things he did well, things he can improve?
I think he did really well. I do not have anything specific.
Okay, thank you, Siva. Anyone else? Yeah.
Yeah, I think he did a really good job explaining his thought process, speaking out loud, drawing the diagrams. He seemed he had a good handle of the tool, except the trial thing, but it's just a minor thing. One thing I guess I would recommend is that I guess early on, not mention any specific technologies, like for instance Redis. You can say you can use a cache, but if you say a specific technology, the interviewer might like ask you a bit more details on like why you pick that technology, why like more details, or like how would this compare to like for instance memcache. So maybe just stick to high level components, and if the interviewer asks you like what component you would use for this particular, what technology you would use for this particular component, then you can dive deeper. But overall, I think it was really great.
Thank you so much. I will definitely taken this feedback into account. Thank you.
Cool. Who would be next?
Yeah. Hi, this is Pradeep, and I think Raghav did really good. Given that this is a quite tricky and interesting problem which covers most of the things, and given the amount of time which we had for this problem, I think he had covered most of these areas, including the rate limiting algorithm, the bucket algorithm, which he has covered. Just one feedback which I think he has already realized and discussed, that sometimes I mean this is also happened with many of us, that we sometimes zoom in quite a lot, and then we need to zoom out and then think about the problem, so that we do not overcomplicate or over engineer few things, and maybe that way we can drive the discussion around.
Yeah, this is Sudhakar here. I think the candidate did good in terms of capturing the requirements, as well as also adding modules, like for example registry. And one place where I liked was where the interviewer asks, like, how are you going to refill the bucket, like what's the idea behind that? And then he mentioned, among various things, he also mentioned something called job scheduler. So that's a good service to introduce over there. So decomposing into multiple different services, that's very good of the candidate. That's all I have. Thank you.
Thank you, Sudhakar.
Okay, anybody else?
Yeah, I have one feedback. You did really good in terms of go to the previous diagram on top.
Yeah.
Yeah, in that I really like the way you went from client, rate limiter, API, and then slowly you added more components to it. One thing is initially you asked questions about API versus IP address, not API, IP address versus
Client ID.
client ID. But later on, you never mention any of those in whether they will take a factor or their parameters that you can use. Little bit more about token bucket algorithm would have been good. Explanation of some of the pros and cons of it, and what because that is the key here, right? For the whole rate limiter. Other than that, I think you did great.
Thank you so much, Praveen. I will definitely improve with my next session.
Awesome. Okay, I think now I can give my quick feedback. So yeah, Raghav, you did really well. In the start, I felt like you were asking requirements, but I want I was wondering like when you will start writing it. So I think as soon as you start, you can start writing the requirements there itself. And you broke, I think, into function, non-function. That was good. But I think generally we also recommend there could be another section of estimates. So then you yourself will know like, okay, this is functional requirement, this is non-functional, this is my estimates. Because estimates we haven't done so properly. Like, what if there are billions of requests, million of requests? Like, what would happen at that point of time? Like, would this system? So it's basically like a contract between you and the interviewer. If you write, then I think that would help you to organize things later in the interview. And in terms of requirements, I was wondering, like, would you could also have asked, like, hey, who's my customer? If you want to show customer obsession, and why we want to build the system. Like, can't I live without the system? Why actually we need this system? Then this will give an impression like you are not just building it, you're first thinking like, if I don't build, can we live with that or not? That is another point I thought to bring. And then overall, I think you did a good high level design, and you knew what you want to design and good use of that tool. So that's nice. Yeah, so you also bring algorithm, which was good. And like Praveen mentioned, you could have talked about pros and cons, but I would say like, before doing couple of things, you can even ask interviewer like, hey, you want me to go into pros and cons? Might be the interviewer is not interested. Interviewer is interested in some other area. So there is always good, like after few minutes, like do a check like, hey, I like, is it something you want me to do more deep dive, or are you fine with here? Because for me in this interview, I was not bothered about algorithm. Algorithm was not my product in this interview, because I can bring any algorithm later and see how it works. Right now, I want to see how your components work, how they communicate each other. That's what I want to see. And then I want to see how things work in your back end. I think you picked up good hints. You steered the interview in the direction in which interviewer was looking for. So which was also nice. And again, like at the end, I gave you a challenging question, like what will happen if this thing there. I just want to see like how much you are exposed to other kind of systems, because the reason why I brought to see, so there could be a couple of ways you can do API rate limiting. One way is like what you did. It's basically different component handling. It could be like you're at your API level only, you can do it. So that time we don't need all these things, and there could be other kind of a alternate design which we can pursue. And then I just wanted to see like, have you exposed to that? I want to see that trade-offs between these two, and see in which situation where you will use design A versus design B, and it could be hybrid also in some situations. So overall, I felt like it was good. You can practice more, and I think you would be. I think you will do really well in your real interview. Okay.
Thank you so much, Aseem. This is really going to help me a lot.
Okay, cool. So with this, the interview and the feedback section is over, and we can now deep dive on any technical aspect. Raghav can ask question, for other people can ask question. We can have an open discussion over here. But before that, I want to see. I want to take any nominations for the next week. Next week we can either do because we did a mock interview this week, so we can do a presentation next week. So anybody wants to present a topic next week can volunteer right away.
Maybe I can take it up.
Okay, Raghav.
If we, I'm first. I would like to give opportunity to the audience. If no one is raising hand, then I would be okay.
Raghav, you can probably give the same rate limiter and throttling industry standards and how they are being used.
Yeah, but
Sure.
is there
It
anybody
would be
else?
a problem specific, Aseem, or it would be like a particular topic like a DB, NoSQL kind of stuff.
I think it could be anything. It like Praveen mentioned, it would be API rate limiter. Like it could be you can present in a different way how you want. Like deep diving on algorithm could be one thing.
Yeah, that is a good idea. I think algorithms, deep diving on algorithms about
It
rate
could be
limiter.
anything which you want. See, basically, it will help you both ways. Like you will learn, we will also learn. You will present, we will get to know things.
Sure, absolutely. So what I will do, I will post my final topic in a Discord, but I would align to this rate limited deep diving algorithms. Thank you.
Sure. And can you sign up on the sign up sheet then?
Sure, I will do that right away.
Awesome. Okay, and that would be January 29th. Anyone wants to nominate for a mock interview for February 5th?
Again, it's me, Raghav. I'm so sorry. I really don't want to take all the slots. I really want to challenge myself in terms of mock interviews right now, the kind of phase I'm into right now. So I'm interested for the mock interview as well. I'm completely fine if I'm taking up or eating up all the slots. I can give up my deep dive topic slot to someone else, and I can pick up the next mock interview. If no one is interested, I'm okay to take both.
No, but I will take. Yeah, want to give opportunity to others also.
Yeah.
So, anyone interested in mock interview on February 5th, 9 a.m.? Okay, we have.
We got
Chiranjeev.
one.
Hi.
Chiranjeev.
So, Chiranjeev, can you go and sign up over here as a candidate?
Yeah, actually I tried to I just opened and authorized that link that you shared, but I think it automatically signed up for 129, so I think we need to cancel that and sign up for the next session. I don't have the slots for the next session available though.
Sorry, I didn't get you.
There's a sign up / design sessions